Hi, this is Chuyang Lin, and this Spotlight Talk will be focusing on the topic of do quality indicators prefer particular multi-objective search algorithms in search-based software engineering. This paper presented an empirical evaluation and provided evidence to help users to choose a MOSA that is highly likely to produce solutions which is satisfied in qualities measured by a QI by users. The motivation and the reason why this aspect is important is because in search-based software engineering, researchers typically select a set of multiple objective search algorithms for their experiments without any justification, or they simply choose a MOSA because of its popularity. On the other hand, users know certain characteristics of solutions they are interested in. Such characteristics are typically measured with quality indicators that are commonly used to evaluate the quality of solutions produced by a MOSA. But imagine in this situation where users already know which quality in solutions they preferred and only wants to select one suitable MOSA without spending extra time to compare multiple MOSAs, which are often expensive. Indeed, in practical context, users have limited time budget to run experiments involving multiple MOSAs and would like to select one that produces the best solution in terms of preferred QI. Thus, in this paper, it aims to provide evidence that is useful for users to choose a MOSA that is highly likely to give solutions satisfying qualities measured by a preferred QI. There are 5 steps proposed by the paper to design the empirical evaluation. Step 1. Execute all MOSAs on the problems and get the result. Step 2. Execute all QIs on the result. Step 3. Perform pairwise comparison between MOSAs for each problem using each QI. Step 4. Calculate preference count for each MOSA and each QI. Step 5. Compute preference count per problem for each MOSA, QI, and each problem. The last step is to perform pairwise comparison between MOSAs for each QI across all problems. At this stage, here comes 2 research questions. How frequently a QI prefers a particular MOSA, and how frequently a QI prefers a particular MOSA across the different SBSE problems. According to these 2 research questions, the paper presents experimental results in this table, where HV stands for hypervolume, IGD stands for inverted generational distance, EP stands for epsilon, GD stands for generational distance, GS stands for generalized spread, ED stands for Euclidean distance, PFS stands for Pareto front size, C stands for coverage. Based on these results, we can see that some QIs seem to prefer particular MOSAs. For example, HV prefers NSGA2, and the SPEA2 is preferred by GD the most. This observation suggests that NSGA2 may have some characteristics that are preferred by HV, and the SPEA2 has some characteristics that are preferred by GD. Giving a summary of the results in terms of which MOSA are most preferred across all the QIs in this table 2, we can see from the table that NSGA2 and the SPEA2 are on the top rankings, which means that these 2 MOSAs are the most preferred ones by most of the QIs, except for the case of SMPSO for GS for rank 1 and cell DE for rank 2. We can also observe that PAES is least preferred by 7 out of 8 studies QIs. And for PFS, MOSA was least preferred. For research question 2, this table 3 reports the overall results from the statistical test they performed. A number in a cell of the table means the number of times that a MOSA was significantly preferred over other MOSAs. For example, with respect to GD, NSGA2 was significantly preferred over other 4 MOSAs. For my personal point of view, this paper provides the clear concept on why it is important to study the relationship between QIs and MOSAs, and this paper provides detailed steps on how it designed the empirical evaluation process. And also, this paper also provides experimental results and analysis on it. What's more, it also provides GitHub link where all data and source code they have been stored. Where I think this paper can be improved more by testing more different MOSAs and QIs pair on different SBSE problems. And that's all. Thank you for your patience and thank you for watching this video.